Hello guys, welcome to Pepcoding, and now I'm going to start with the next question. Construct a BST from level order traversal. So in this question, we have been given one level order traversal, and with the help of this array, we are going to construct the BST. Okay, so this is our question. So we are going to construct the BST from the level order traversal. So let's go and discuss this question. So okay, so in this we have been given this level order array, and then what we have to do, we have to construct this tree, okay, using this array. Okay, now I hope your question is clear. So how can we do this? So before telling you the approach, I would like to tell you about what is level order. I know you already know this, what is level order, but I'm going to tell you what is level order traversal. Level order traversal is something like this. Traversal horizontally. First it will come 50, then 17, 72, then 12, 23, 54, 76, then 9, 14, 19, 67. So this is actually the level order traversal. Okay. So now let's go and discuss the approach. So how we are going to do this? So for this, I'm going to take one queue. Okay, I'm going to create one queue. So this whole space is our queue. Okay, and in queue, what I'm going to push is I'm going to push the one pair class. Okay, one pair. It can be anything. I can let me take level pair. Okay, so in question also it is given it. Okay, so we are going to push the object of level pair. Okay, so what is stored, what we will store in this level pair? So first I'm going to store the parent. Okay, so first I'm going to store the parent. Then what I'm going to store, I'm going to store the lower bound and right bound. Okay, what is lower bound, right bound? So you have already seen my last videos, so you already know about this, what is lower bound and what is right bound. It is not lower bound, it is left bound, and it is right bound. Okay, so we have to create the BST, so we need to specify these ranges. Okay, so we have to work with these ranges, so that's why we are storing the one object in which we are going to store one parent and the two things also. First is lower bound and the second not lower bound, left bound, and the second one is right bound. Okay, so for this, what is the range for this? So we already know the range for this is minus infinity to 50 or 50 to infinity. Okay, so this side we are going to store the node for this range, and to the right side we are going to store the node of this range. Okay, so that's why we are going to deal with these left bound and right bound ranges. Okay, so we have discussed what we are going to store there. So before like moving forward, I would like to specify the ranges of each node. Okay, so what will be the range for this? So the range for this is minus infinity to 17. Okay, so the all the element to the left will be the smaller than 17 and greater than minus infinity. Okay, and what is the range for right side? Right side will be 17 to 50. Okay, so this is left bound and this is right bound. Left bound, right bound, and this is left bound, right bound. This is also left bound, right bound. Okay, so what is the range for this? The range for this is minus infinity to 12. Okay, minus infinity to 12, because in the range for this is they can be smaller than they can be smaller than 12 and greater than minus infinity. Okay, so what will be the range for this side? So it will be greater than 12 and less than 17, because we have already specified there, like they will be less than 17. Okay, so the range will be 12 to 17. Okay, so like this we are going to specify the all the ranges. So what I'm going to do is I'm going to store the pair. Okay, so like there are no nodes, so by default what we are going to store, we are going to store the 0, not 0. Parent will be null. Okay, so parent will be null. And what is the value of LB? LB will be minus infinity to infinity. Okay, so in the starting we are going to store null and minus infinity to infinity in the queue. Okay, so we have inserted one element in the queue. Then what I'm going to do is I'm going to take one IDX variable. I'm going to take one IDX. Okay, so I'm going to iterate this IDX one by one in this array, and I'm going to like fit this node into the correct position in the binary in the BST tree. Okay, so this is our BST. So here I'm going to create the our BST. So I'm going to fit one by one. I would like to fit the correct position of this element, each and every element. So right now there is no element, so this will be our root element. Okay, so let me discuss the process how we are going to do. Okay, so first IDX will point to the 0th element. So first IDX will point to the 0th element. So what I'm going to do in this is I'm going to pop the element first. So first I'm going to take a pair variable, and I'm going to store this value and pop it. Okay, so I'm going to pop this, or you can say remove this from the queue, and I'm going to store this in pair class. Okay, so this is actually our parent. So it is null, so null is not a parent. Okay, so then after that what I'm going to do, the second step is I'm going to check this whether this element lie in this range or not. Okay, so let me write all the steps here so that it is easy to code us. The first step is I'm going to pop, you can say remove the element in queue and store it in pair variable. Okay, first step is this. The second step is to check the node, check array of IDX, that we are going to check the element in the range, okay, if not then we are going to continue. So first there is null, so if the parent is null, then what we are going to do, if the pair of parent is null, then we are going to create the root node. So this node will be the root node. Okay, so this is what we are going to do. So first I'm going to see that whether this is a root node or not. So if this is a pair class, this is actually pair variable, so I'm going to read the pair of parent. Okay, this is parent variable, then this is left bound and this is right bound. Okay, if the pair of parent is null, then I'm going to create this as a root node. Okay, and this lies in this range because this is minus infinity to infinity. So this is our root node. Okay, then I will increment the IDX. Okay, then I forgot one step. Like before incrementing the IDX, what I'm going to do is I'm going to store the two things, that is this range and this range. Okay, not I'm going to store for 50. Okay, so first what we have to do, we have to store this range as well as this range. Okay, so we have to push the object in the queue. Okay, and in which we have to set the lower bound and right bound, not lower bound, left bound and right bound. And then again in the second object we are going to set this left bound value and the right bound value. So what I'm going to do, I'm going to push the two object, and what will be the parent? Now the parent is this 50. Okay, so 50, I'm going to push it like this. Now what will be the lower bound? Lower bound will actually equal to the minus infinity, and the right bound will be the node dot val. Okay, so this is actually a node of val, that is equal to the 50. Okay, then here it is node dot val or up to infinity. So this is what we are going to store in queue. Okay, now let's move to the next iteration, that is idx will increase. Now what we will do, we are going to check whether this node will insert in this or not. Okay, for this what I'm going to do, I'm going to pop this, and now pair will be pointing this. Okay, now the pair will be pointing this element. Now this is the pair. Okay, so does this array of idx uh, is in the range of this minus infinity to 50? Yes. So if this element array of idx is come under in this range, from left bound to right bound, between left bound to right bound, then what I will do, I'm going to create a node. Okay, so I'm going to create the node, and then I have to insert this node. Okay, now you might be thinking like, where I will insert this node, to the left of this parent node or to the right of this parent node. You might be thinking like, where it is a genuine question actually, where we will insert this node, to the left side or the right side. Okay, so let me write some steps. So I have written the second step, that is I will check whether array of idx is in the range or not. So if yes, if this condition is false, then what I'm going to do, if this condition is false, then I'm going to continue it. Okay, so I'm going to again repeat the same step, that I like to pop the element from the queue and check for the another element. Okay, suppose this condition is true, then what I'm going to do, then I'm going to create a node. Okay, the third step is to create a node, create a node of array of idx. Okay, the value will be the array of idx. So again what I have done is I have created the node. Now I have to set it. Okay, so now I have to set it. Now where we will where this node will go. Okay, so what will be the condition for this? Let me specify this. What will be the condition for this, like whether we the 17, we have already seen like 17 is in the range, but we don't know whether where it will come, to the left side or to the right side. Okay, so if this node of val is less than parent dot null, pair dot parent. Okay, if this value is smaller, then we are going to attach to the left side. If this value is greater, then we are going to attach to the right side. Okay, let me repeat again. If this node value is smaller than this value, okay, if this value is smaller, then what we are going to do, we are going to attach to the left side. If this value is greater, then we are going to attach to the right side. Okay, let me repeat once again. If this value is smaller, then we are going to attach to the left side. If this value is greater than this value, then we are going to attach to the right side. If this value is smaller to the parent node, then we are going to attach to the left or right, because we already know, like in BST, all the values are all the smaller values are to the right side, to the left side, and all the greater value are to the right side. Okay, so this value is smaller than the parent node. Okay, so parent node of value, this is actually the smaller, because 50 is greater and 17 is smaller. Then where we are going to attach, we are going to attach here. And then what is the next step, we have to set the range for this, like this value, this range. Okay, so let's do this. Let's set the range 17, 17. This is our parent node. Now this will be our parent node and there will be some more child. Okay, so what is the value of left bound? Left bound is actually equal to the left bound, that is minus infinity. And what is the right bound? Right bound is equal to the node of val, that is 17. And in case of right, so left bound is equal to the node of val, that is 17. And what is the value of right bound? Right bound is actually equal to the right bound only. Okay, that is 50. Okay, so we have also set this value, these two ranges. Now again, we will repeat the same step, that is we are going to pop the element and we are going to store in a pair. Okay, now again we are going to check for the next idx. Now the next value will come, next idx will come. Now it is going to check for this range. So does this 72 lie between this range? Okay, whether this 72 lie in between this range? Yes, it lies. So what we will do, we will just create a node. We'll create a node. And now I'm going to check it whether it will come to the left side or to the right side. Okay, now I'm going to check to the left side or right side. So what is our root parent node? Parent node actually is 50, because we are going to store in, we are going to attach this value, this node to this parent. Okay, that's why we are checking for this. So does 72 is greater than or less than 52? It is greater than, so it will attach to the right side. 72 is going to attach to the right side. Then what we have to do next step? Next step is to set the range 72, 72. Okay, for the left bound, the range will be equal to the left bound only, left bound 50 to infinity. And what is the value from this? For this value, this value is actually equal to the, so let me write, so it will equal to the not 50. So these value are always greater than node dot val. Okay, so what is the range for this? So the range will be 72 and infinity. Okay, so the range for this is 72 infinity, and for this side 50 to 72. Okay, these are the ranges for this. So this range we are going to store it here. So 50 to node dot val, that is 72. And what is the range for this? The range for this is 50 to infinity, not 50, 72 to infinity, 72 to infinity. Okay, so we have also stored the range for this. Now I'm going to see the next one, that is I have set this. Now I will increment the idx value. Now the idx will become this one, 12. So first what will happen? So first we will check whether it lie in the range or not. So first I'm going to pop this and store it. So does 12 lie in this range? Yes, this lies. So what I will do, I will create the node. I'll create the node. Then I have to check for the parent, from the parent, whether this value lie to the left side or the right side. So this is our parent. Okay, because this 17 is our parent. So this value is smaller, so we have to lie left side. Again we are going to set the ranges 12, 12. Okay, left bound will actually become in minus infinity to dot val, and then I'm going to check for change for this value 12 to 17. Okay, so again now I'm going to do little bit quick. Then again we have stored this, then again I am going to erase this. Then I'm going to check for the next one, that is 23. So first I will check for this one. I'm going to pop this, and now I'm going to check for this range. So does this lie? Yes, this lies, 23. And now where we have to attach, we have to check with from the this parent node. The 17 is smaller. Yes, smaller. We have to attach with right side. Then again we have to do the same step. Okay, so we have to just repeat the steps. So let's go and code this. So we have to code this in C++. So let me do C++ and do the full screen. Okay, So this is our pair class as we have seen it here. Okay, so as we have seen it here, this level pair class, so it is given here. So this is level pair class in which we have been given the parent, in which we are storing the parent node, and then what we are doing is we are storing the two more value, that is left bound and second one is right bound, and there is one constructor also which is setting all the values. Okay, so first what we have to do, first we have to create one idx. Okay, so first I'm going to create one idx and queue. So let me create one idx index idx, and it is starting with 0. And then the second thing which I'm going to do is I'm going to create one queue. Okay, so queue, and the type of this is level pair pointer. Okay, so this is our queue, and in starting we are going to insert this the default value of this. Okay, so in queue I am going to push it. Okay, so I'm going to push an object of pair type of level pair. Okay, so I'm going to copy it from here, level pair. Where is our queue? There. Okay, so it will give us the default value. I'm talking about this. I'm talking about this thing. Like in starting, we are going to insert the null minus infinity to infinity. Okay, then what are our next step? Now our next step is to check it. First, I have to use the while loop. Okay, so first what I'm going to do is I'm going to check the while loop, and then I will do these steps. So first I will use one while loop for iteration in the array as well as in queue. Okay, so first I'm going to use the while loop, and what is the condition for this? So if idx is smaller than array of size, the first condition is this, and what is the second condition? The second condition is if queue dot size is greater than 0. If there is element in the queue, then we have to iterate this while loop. Okay, so this is set, and the next what we are going to do is we are removing the element in the queue and store in the pair variable. So let's create one pair. Okay, so level pair, and we are taking one pair variable, and what we are doing, we are removing, so queue dot front, first I'm storing it. First I have to store it, and then I have to pop it, queue dot pop. Okay, so I have done this step also. Like first I'm storing this, and then I'm going to remove this. Okay, so I have done this step. Now what we have to do, now I have to check whether the array of idx is in the range or not, or I can also say that whether this the top element of queue will be the parent node or not. Okay, so let's check this. So what we have to check, if array of idx, if array of idx is in the range or not. Okay, so I have to check whether this node is in the range or not. Okay, so where is the range? The range is in pair. Okay, pair of LB or pair of RB, that is left bound or right bound. If the array of index is less than left bound, that is it is out of range. Okay, or I can say that if array of idx is greater than right bound, that is then it is in right side. Okay, out of the bound. So what I will do is, if array of idx is smaller than pair of LB, that is left bound. If this value is smaller, than the left bound, I'm talking about this. Suppose this is our left bound, and comma there is our somewhere around right bound. Okay, if array of idx lies somewhere less than left bound, then it is out of range. And if array of index is greater than right bound, then it is lie in this region, then it is also out of the bound. Okay, so we have to use this condition. So we will use array of idx is greater than pair of right bound. Okay, then it means it is out of the bound. Okay, then then in that condition what I will do is I will use continue. Okay, now what I will do, if this is in the range, then what I will do, I will create the node. Okay, so let me shift it here. Then I'm going to create a node. I have done the second step. If this is correct, then we have to create the node. So how I am going to create the node? Free node, that is node equal to new tree node. And what is the value of this? The value of this is array of idx. Okay, array of idx, and we are going to increment the idx. So idx plus plus. Okay, so we have done this also. Now what we have to do is I have to set this node. Set this node to root node, or I can set this to the left parent, left side of parent, or right side of the parent. Okay, so I'm going to set it to the left side or right side or to the root. Okay, so the checking for the root is very easy. So if pair, see, when we are setting the root node, if pair of parent is null, then it is clear. If pair of parent is equal to null, then it was clear that it is our root node. Null ptr actually it is. So root is equal to the node, but we have not initialized this root variable. So let's initialize it. Root variable tree node root is equal to null ptr. Okay, we have also initialized it. Okay, so else what we have to do? Else it will come to the left side or to the right side. Okay, so how we are going to check that to the left side? So we already know, if pair of parent of value, okay, if pair of parent of value is greater than the node.val, then in that case we have to shift it to the left side. Okay, so let me write it, then you will better understand this. If node of val, that means these values, I'm talking about these values, if this value is smaller than the parent node, then what we have to do? Then that means this is to the left side. Okay, if this is smaller to the pair of parent of value, okay, if this is smaller, then this means it is to the left side. Else, right after the command, else it is to the right side. Okay, so I will just set the value pair of, let me give the one tab, pair of parent of left is equal to the node, and we have set this node to the left side, and I'm going to set to the right side also. Okay, so we have also completed this step, and in the end what we have to do, we have to add these two things to the ranges, to specify the ranges in the queue. So I'm going to add this. So this is our QUE.add. I'm going to add these two objects. Let me copy the name. new of level pair. Okay, level pair. And now what we are going to do, we are going to give the names. Okay, so first I'm going to set the parent. This is the parent, and left bound, sorry, left region and right is the name of variable. Let me left bound and right bound, left bound or right bound. Now what will be the value of these left bound and right bound? So let's see it for here. So I'm going to specify this range, this minus infinity to this minus infinity to 30. I'm going to specify this range. Okay, so what is the value of this range? The value of this range is actually, this is you can see it here. What is the value of, we will discuss for this, what is the value of this? This will actually equal to the left bound only, and the right bound will become the node of data or node of well. Okay, so you can see it here also, that this is becoming the left bound only, this is equal to the left bound only, and the right bound is changing, it is changing to the node of well. So let's do this only. So left bound will become as it is, left bound, and right bound will become node of well. Okay, so let's copy this also. And now what will be the right range? So the right range is equal to the node of well, and right bound is equal to the right bound only. Okay, so let's change this also. Node of well, and this is changing to the right bound only. But we have done some mistake. This is pair of left. Okay, actually we were talking about the pair. Pair, we were talking about these values, these pair values. Okay, so now we have inserted this. Now what we have to do, we just simply have to return the root node. Okay, in the end we are going to return the root. Okay, so I think we have covered all the steps. So let's run this and check for the compile time errors. So let me fix the errors. So the error was in 71th line, 71 and 72. Let me check this. Okay, actually I have written the wrong method. Okay, so this is actually not add, this is push. This is how we insert the value in queue. So let me run it now. So it is accepted. So let me check for all the test cases, and all the test cases are running fine. So thank you guys for watching this video, and we'll meet you in the next video.